John White promised by
Hello, good evening, everyone. Hello, hope you cannot hear me. Hello, okay. Let me just use my phone, my system. I don't know. I've been trying to connect. I was locked out. Hope you can all hear me, please.
Good evening. Can hear you.
Oh, yeah, I don't know. I was locked out. I've been trying to connect through my system, so because I want to share my screen with you guys. Has been our day. I'm still with you. I'm still trying to connect through my system. Let's see what happens. Let's just chat more before as my system is still connecting. So how was our day? Able to connect. What happened? Grace, how was your day? Femi, Prince, and Uduka. No one is talking.
My day was fine, ma'am.
It was fine, thank you. How was yours too?
It was fine and hectic. It's okay. What of Prince? Sorry, I'm trying to connect. I want to show you my screen, but I don't know. Maybe let me log out and log in back. Prince, how was your day? And Uduka. All of you are not Lagos people, Sha. How many of us are from Lagos? Who is in Lagos? Sorry, I can't hear you very well. Please, can you speak louder?
I stay in Lagos too.
That's Femi Uduka. Who is that?
No, this Prince.
Prince. Okay. How is Lagos?
Lagos is
Lagos
fine.
and traffic of it.
Eh?
I say Lagos and traffic.
Yes, so I'm on transit at the moment.
Wow. Okay, I understand. I understand. It's okay. Sorry, I think I'm going to just run the go through the course now because I don't know, my Zoom is not connecting. I've tried joining the meeting again and again using the link and it's not coming up. And I want to show my screen so that we can start today's class. It's not coming up. This is serious. Okay. Let's see how far we can go. I want to show you my screen because if I start teaching you, I want you to look at the screen so that you can get what I'm saying. I'm trying to log in back with my system. So today we'll be having a new topic for the week. Come up, please. Please just come up. Oh, this is this phone. Yeah, still 6. I think most people are on transit. Okay, you know what? Let me share the link to the group. Let me share the link so that I can just go through it because I can't connect with my system from here. So let me share the link so that you can just go through it and I can explain from here. Is that okay by us? Let me share the link. This is not coming up on my system. Come up, please. Oh, that's nice. Okay. Let me just share us the link so that can know on our system. I'm so sorry, please. I'm with you guys. Trying to. I don't know why this is not. I'm able to connect. What happened? I'll check it later. Yeah, check the group page. I've sent in the link. You can actually access it through. So I'll be explaining from this end. So everybody should click on the link. I'll be explaining from this end so that I won't waste our time. Have you all seen the link? Have you seen the link? Please check the group page, please. Please, no one is talking. Have you seen the link I sent? Can you all hear me, please? No one is talking.
Yes, ma. I've seen the
Please,
link.
you've seen, please open it on your phone so that I can explain from here. Let me show down the system. This is not just coming up. Okay. Good evening, everyone, once again. Now, let's go into our topic for today. And today, we'll be dealing with a new topic, Introduction to Cryptography. Can you hear me? Am I audible? Can you hear me, please, before I go on?
Yes, you're audible, ma.
Okay. Okay. Introduction to cryptography or cryptography, how you know how to call it. Introduction to cryptography or cryptography, anyone. Now, fundamentals of cyber cryptography and security policy, but today we'll be looking at the introduction to cryptography. Now, what is cryptography? I don't know if you have heard of something like cryptocurrency, what is crypto? Now, as Sorry, can you hear me, please? My network from my end is bad. Sorry. Can you hear me, please?
Yes, ma'am, we can hear you.
Okay, let's just go on because of our time. Introduction to cryptography. Now, when you hear the word cryptography is just the practice of hiding or coding information so that the person you're trying to send the message to can only read it. Another person won't have access to it. So it means you're trying to convert the plain text, into a code that cannot be read, or that any other person that sees it can actually know what was there, cannot get access to the information because the person doesn't understand. You have already changed it from a plain text. You have converted it now into another form that is unreadable by any unauthorized user. So cryptography is the practice of securing communication and data by converting it into a form that is unreadable to an unauthorized individual. So if you're trying to send a message to me now, maybe in the group, and you don't want another person, anyone else to access it, you can actually encrypt it. Now, why do we need to encrypt our data? It's because so that unauthorized individual or unauthorized person can't have access to it. So cryptography is the process of hiding or coding information so that only the person you want to send, the intended person you want to send the message to, can actually read it. So, and cryptography has been in existence for a long time ago now, and banks use it, computer password and e-commerce. So it is a method that is being used over a long time now, and every various firms, various sectors use cryptography now. And we have the modern technique also that can be used. Excuse me. Modern cryptography techniques that can be used also enable encryption and decryption of information. Now, if we want to send message now, we have modern encryption tools that we use, like the AES, that is the Advanced Encryption Standard. Now, go back to the introduction to cryptography, and let's see. Now, it says it involves the use of encryption and decryption techniques, as well as various cryptographic algorithms to protect sensitive information from being accessed or tampered with. So the reason why we're actually converting our plain text or what we try to send to other person or anyone is that our data, our information can be protected and cannot be tampered with. So it has to do with confidentiality. Can you see it? It has to do with what? What else do you see? You see the word tamper with. What does that mean? Is that availability or integrity? This has to do to protect sensitive information from being accessed or tampered with. Yeah, this is confidentiality. What is this one? Or tampered with? What is that? Is the availability or integrity? Before I go on.
Integrity.
Yeah, that's correct. Now, cryptography can be traced, it actually originated from the Egyptian, and it remains the vital way of securing communication information in transit. It is when you're trying to pass information, that if an information data that is traveling out of your network. So you are trying to prevent it from being read by an untrusted party, so that any other person can have access to it or cannot know what you are trying to send. So, and by this, we make use of algorithm and mathematical concepts to transform messages into difficult decipher codes through techniques of cryptography, so that the person that actually even by the way of your data traveling through the network, even if the person come across it, the person cannot read it because you have already encrypted your data or your information. So you can only, for anyone to actually decrypt it, it means that the person has to have maybe the key also. So, and if the person doesn't have the key, there is no way the person can actually, open and have access to your file or to your data that you are trying to send across the network. Now we have common cryptography algorithm. Now we have the AES, that's the advanced encryption standard. Now this advanced encryption standard now, it does has to do with, when you hear advanced encryption standard, now it is, you can call it a symmetric encryption algorithm, and that one is used for securing sensitive data. Now it supports key size of 128, 192, and 256 bits. Now I said when you want to, in cryptography, we use engineering. No, it is just a combination of different field. Now, just like discipline like computer science, engineering, and mathematics, in order to create, the reason why we're actually doing this is that to create a complex code that we hide the true meaning of the message. So it's not, that's why, because when I was mentioning keys here, 128, 192, 256 bits. So it has to do with mathematical, mathematical codes in order to, to hide the true meaning of the message you are trying to send. So that is the reason why we're actually encrypting our information across the network. Now, and we have the, sorry, excuse me. We have the RSA, the reverse Shamil Adleman. Now, that one has to do with asymmetric encryption algorithm. Now, that use the same public key and private key pairs. It's commonly used to secure communication and digital signatures. Now, that one is used to secure communication and digital signatures. Now, the RSV, now, this RSA, it is based on mathematical properties of a prime number, by generating two large prime number, maybe P and Q, to calculate their product. Now, and the scalability, the verification signing. So this actually has to do with numbers, generating numbers, mathematical properties in order to encrypt your information or your data so that unauthorized individual or person won't have access to your information. And another one that we have is the DES, that's data encryption standard. So that one is a symmetric encryption algorithm that uses 56-bit key and is commonly used for legacy institute, but has been largely replaced by AES. Now, when you hear asymmetric, you hear asymmetric encryption. Now, asymmetric encryptions use two pairs of keys. That is the public key and the private keys to encrypt data and to decrypt data. Now, the public key encryption, that one is used to, secure communication over an unsecure network, such as the internet. So that is why we have the asymmetric, in order to secure information or your data across the internet. So unauthorized user won't have access to your data. And we have another one, the SHA, that's secure hash algorithm. Now, this secure hash algorithm is a family of cryptography hash function used for data integrity and data signatures. Now, the SHA 256 is commonly used. Now, when you hear the word digital signature, as you can see, we hear digital signature. Digital signatures are just, their unique string of characters that is generated during the digital signing process. So what they do is that they try to send a private key and they sign the data. So it has two functions just for authentication and integrity. So this digital signature, it is created by using sender private key and the signed data. So the digital signature are just a unique string of characters generated during the digital signing process. Now, that is the SHA, that's the digital. Hope you are all seeing it from your end there, right? Hope you are seeing these things I'm saying. Hello, hope you are all seeing it.
Yes, ma, we are.
Okay, so and we have the Diffie-Hellman key exchange. It's an asymmetric encryption algorithm used for secure key exchange between two parties over an unsecure channel. Now, this algorithm, now when you hear a secret key also is known as a symmetric encryption. Now, this symmetric encryption uses a single key to encrypt and to decrypt message. Now, a symmetric encryption, it uses a single key. That is, maybe I'm the one that is sending you a message and I've already encrypted it. No. Now I'm trying to send you the data or the information, the message over the internet. Now, this is what will happen. I'm the one that actually encrypts it. So I have to send you the key for you also to decrypt the message when it comes to your hand there. So the sender will encrypt the plain text message using the key and send it to the recipient, who then also use the same key to decrypt it or to unlock the original plain message. Do you get it? The symmetric key? Do you get it, please? Hello, do you get it?
Yes, we got it.
Yes,
Okay,
ma.
fine. Okay, so I'm trying to explain because the AES, I explained asymmetric, and also asymmetric and symmetric. Now, I said the secret key is also known as the symmetric encryption, and that one uses a single key to encrypt and to decrypt messages. So if I'm sending you a message, I will also send you the key also for you to decrypt it at your end so that you can change it, because from my end I'm actually converting a plain text, maybe just like a letter you're trying to write a mail, but I don't want any other person to access that. It's going through the network, through the internet, so I will decrypt it into a code that nobody can read. So, and for you to read it at your end when the message gets to you, I have to send you the key also for you to decrypt it from that code back to the plain text, the original plain text message. Do you get that? Now, another one that we have is the asymmetric. The asymmetric encryption. That one, the asymmetric also is the public key. Now, you can say a public key or a asymmetric cryptography. Now, this uses a mathematical function to create codes, that are exceptional and difficult to crack. So the reason why we are actually using this public key is that, and this mathematical function is that, so that people, when you are trying to communicate over the network, now, so it enables you to communicate securely over the non-secure communication channel without any need for secret key. Now, you don't need a secret key in public key. Now, the difference there is that when you are using a public key, it doesn't require access to a plain text or a private key, because it's a public key. It has a proxy re-encryption that enable a proxy entity to recrypt and re-encrypt data from a public key to another any key without requiring a normal private key. So this asymmetric key, that one also use a large number prime number. So it enables them to create each resulting number so that you cannot, decipher the message on the network or on the internet. So the reason this asymmetric is that increases protection to point that computer are capable of combining different keys and cannot track and for people, for unauthorized user to crack it. So that is asymmetric. Now let's look at the basic principle of cryptography. Now, basic, I'm looking at the slide here. Okay. Now, let's look at the types. Let's look at the types of cryptography algorithm. Now, I've talked about the RSA, and I've talked about that. I don't think I've talked about the ECC. Let me check my slide here. The elliptic curve cryptography. Now that's the ECC. So this ECC, I don't think is in the slide. I'm trying to check on my hand. Trying to check. That person should please mute his mic. Please mute your mic. Okay, now let me talk about this ECC, that the elliptic curve cryptography. That one use an algorithm based on the use of elliptic curve in the cryptography. That one is designed for device with computer that have limited computer power or memory, to encrypt data, to encrypt internet traffic. So ECC, that one is actually a common use. We use ECC mostly in computer, smartphone, or cryptocurrency network like Bitcoin, because they consume around 10% of the storage space. So that is ECC. That one use an algorithm based on elliptic curve in cryptography. So there's a way it is being done. Now, the DSA, that's the digital signature algorithm. So that one, DSA, okay. That DSA, now I think I've talked about that one, DSH. Then let me talk, there is one I remember, the IBE. That one, the IBE means an identity-based encryption. So that one enables the public key. Don't forget the public key. Now the public also can be asymmetric. Do you remember now what I said now? That the identity-based encryption, that is IBE, also enable the public key to be calculated from a unique information based on the user identity, such as an email address. So that is the identity-based encryption. Now, and we have the Diffie-Hellman and key exchange algorithm. Now, this Diffie-Hellman key exchange, I think I've explained that. Okay, let's go to the hash function. Let me see. I should talk about the hash function. Let me see if it is here. Okay, let me talk about the hash function. Now, this hash function now ensures that the data integrity is maintained in the encryption and decryption phase of cryptography. Now, so the reason why we are actually hashing our information, our data, is just to ensure that the data is secured. is not tampered with when you are trying to encrypt it or you are trying to decrypt it in the face of cryptography. So, and this uses a database so that item can be retrieved more quickly. So hashing is the process that take your input, such as maybe your password or any other information, and turn it into a fixed strong byte. These are just in form of letters, your number. Now, and hashing can be used to create a digital signature whereby you can actually use it to authenticate the sender and ensure integrity in the transmission of data. So when you are trying to hash, now you try to hash by adding maybe salt to your password before hashing it. So this is to enhance security of hashing. So it ensures unique identical password, making sure that your information or what you have encrypted, hackers or attackers cannot crack it using some pre-computable, computable tables such as the rainbow or the brute force. Now, that is hash. I think I should explain that before I go forward. Now, what are the basic principles of cryptography? Now, cryptography is the practice. I think I've explained this the other time. Now, the reason why we're actually, what's called using cryptography, we are trying to secure our communication from unauthorized access or modification is that, number one, because of confidentiality. Now, we want to ensure that our data or our information cannot be unauthorized user cannot gain access, cannot understand our information. So that is the reason why we are trying to protect our data, our sensitive data or information, so that unauthorized user or individual or person cannot have access. And even when they have access, they can't understand the message. So encryption is the use of plain text into ciphertext. Now, so what is encryption is all about? If you remember the first time I explained it, so we are trying to convert a normal message, an original text, a plain text, maybe your words into a text that the others, even when they see the message, they can't understand. Now, and another reason why we use cryptography to secure communication is because of integrity. Now, and integrity has to do with you making sure that your information are not tampered with in any form, maybe at rest, in transit. Now, so the reason why we actually try to secure our communication from unauthorized access is that so that our information cannot be tampered with or altered at all. So cryptography hash function are used to generate a unique hash value for data. So any change in this data can result to hash value, so indicating that the data has been tampered with. So when you encrypt or when you encrypt your data or your information, anyone, so what happens is that the hash function that is used to generate each hash value for the data, maybe you are the one that actually hash your information, your data, or your message you are trying to pass across. So if any changes happens to it, it will result to hash value. So it will tell you and actually alert you that your data has been tampered with. So another reason why I cannot cryptography is because of authentication. Now, authentication verifies the identity of the communicating party. Maybe you are who you claim to be. So it tries to authenticate the communicating party. Maybe I am who I claim to be, and you are who you claim to be, the person you are trying to send the message to. So digital signature use authentication. It sends the sender and ensures that it sends the sender and ensures that the integrity of the message is still intact and is not tampered with. So the sender will use his own private key to sign the message. So the person that is collecting it, or the receiver or the recipient, verify that also that message using the sender public key. So another reason for cryptography is non repudiation. Non repudiation. Now, when you hear the word non repudiation, now non repudiation prevent the sender from denying that they sent a message. Is that when you actually do something online, you cannot claim you are not the one that did it or do it, anyone. Now, reason because it makes sure that your signature is linked to the identity of the sender of the message. So non-repudiation has to do with you claiming who you are, and whatsoever you have done, maybe on the internet or in the network, it cannot be associated with any other person. So it makes you responsible for your action online. So that is what we call by non-repudiation. You responsible for the acts you commit online or for what you do online. So you cannot pass it to another person. It may add you responsible for what you do online. So that is the reason why we conduct, we used cryptography. Now, another reason why we use this cryptography is because now, let me see from this end. I've talked about confidentiality, authentication, non-repudiation. Okay. Another reason why we use this, I've talked about integrity. Yeah. Privacy also is also confidentiality. So privacy or confidentiality now, and also authentication, integrity, then non-repudiation. So that's the reason why we actually make sure use cryptography, make sure our message, our communication online is secured from unauthorized access or modification. Now, another thing I want us to look at is the encryption and decryption techniques. Now, the encryption and decryption are the fundamental techniques used to secure information and protect data. Now, how do they do this? How does encryption and decryption? Now, encryption use algorithm. Now, there are several techniques and algorithms used for encryption and decryption, each with its own strengths and weaknesses. Now, number one, we have the symmetric encryption. Now, like I explained the other time, symmetric encryption uses a single key both to encrypt and to decrypt data. Now, the reason why people can prefer to use symmetric information is that it is very fast and efficient, but also requires secure exchange of the key. Now, because if you send the message, you have already, excuse me, encrypt the message. Now, your key also that you send to the recipient or the receiver, also you must ensure that also it is secure, that the key also is secure. Now, let's come to asymmetric encryption. Now, that one use a pairs of key, like I said, a public key for encryption and a private key for decryption. Now, asymmetric is used because of secure communication without the need of a secure key exchange. I think I explained this the other time. Now, hash function. Now, hash function, it generates a fixed size output, hash, from an input of any size. It is commonly used for data integrity, verification, and password storage. Now we have the digital signature. I've explained all this. I think it's only this key exchange protocol I've not explained. Okay, let me just read it from a slide here. Now, digital signature, that one use asymmetric encryption to provide authentication and integrity of digital message or document. Now, we have another one, that's the key exchange protocol. That one exchange encryption key between two parties to establish a secured communication channel. So when you are trying to pass a message to a recipient or a receiver now, so what this key exchange protocol, what it does is that it makes sure that your exchange online, on the network and over the internet, is done through a secure communication channel. Now, we have the SSL and TLLs. Now, when you, I don't know, when you check your email, maybe somebody sent you a message. Now, most of the time when you try to look out to send the message, the mail, where the message was coming from, the source of the message, what you discovered there most of the time is this TLS, and that TLS is transport layer security, or the SSL, anyone. Now, that's transport. If you can actually check your mail and try to see this that I'm saying. Now, it uses transport layer security. Now, the reason why that transport layer security TSL is used is because that this TLL this protocol, it provides a secure communication over the internet, ensuring that data confidentiality and integrity is intact. Nothing is tampered with, nobody has access to it. So that is why we use this TLS. Now, let's look at another common algorithm. Common cryptography algorithms. Now, these algorithms are essential for ensuring confidentiality, integrity, and authenticity of data. Now, the AES. Now, let's look at the symmetric encryption algorithm. Now, symmetric encryption algorithms. Now, look at the slide. Now, number one, we have this advanced encryption standard, the AES. Now, this is the description, this is the key length and the common uses. Now, the reason why we use this AES is because your data can be protected over the world, over the communication channel. And also, we have the data encryption standard.
Sorry, please, are you sharing your slide?
I can't share my slide again. I sent.
Oh, okay. Oh, okay.
I sent the link because I can't share it here. Now, but you can go through it. All this that I'm explaining is inside that slide. I'm trying to just click on it, and I will just explain from my end here. Now, this data encryption standard, the DES, that one, the description, the key length is there, and the common use, you can read that, but let me just read it from here. Now, this data encryption standard, DES, is another symmetric encryption algorithm. This one is replaced. They use this DES, replace this AES. Why? Because of legacy system and application. So it's wider than this AES. Now, and we have the triple data encryption standard. That one is an enhanced version of the DES. So that one applies the DES algorithm 3 times in sequence. So it is 112 or 168 bits. Now, the data encryption standard, that one is 56 bits. And the AES, that one is 128 or 192 or 256 bits. So this triple data encryption standard, the reason why they use it mostly is because of the legacy system and the application. It requires stronger encryption. Now, the asymmetric, that's the first one, the AES, the DES, and the triple data encryption, that is the symmetric encryption algorithm. Now, let's look at the asymmetric encryption algorithm. We have the Reinvest Shamil Adelima RSA. That one is used, a widely used asymmetric encryption algorithm based on the difficulty of factoring large prime number. So that's the reason why this RSA, the description, is because that one it is very difficult. It has a difficult factoring the large prime number. So, and the key length is large. So 1024, that's the bit, the key length 3000. So those are the key length. You can just check the slide. Now, the common uses, the reason why they use this RSA is because of secure communication, digital signature, and key exchange. Now, I think I explained this EECC, the elliptic curve cryptography. So that one's use an elliptic curve and also is for secure communication and digital signature and for key exchange. Now, I think this David Allman, I've explained this the other time. Now, let's come to the security policy. The security policy. Now, what is the importance? Why are we using cryptography? Why are we making use of cryptography? Now, the reason why I'm making use of cryptography is to ensure that our system, our network are secure. So security policy are essential for maintaining secure system and network. They provide guidelines and procedure to ensure the confidentiality, integrity, and availability of information and resources. And also for security policy helps prevent unauthorized access, data breach, and other security incidents. So the reason why we're actually trying to secure all information on our network, everything, is so that there will not be a data breach. No one can have access to our information, unauthorized access to our information, sensitive data. So, and also to establish a framework for maintaining, let me look at my slide there. Shut down. Okay. Now, what are the key elements for security policy? Now, it must be clear and concise communication for security, expectation and requirements, the roles and responsibility. Now, I'm talking about the key elements of security policy. Now, it must be clear and concise communication of security, expectation and requirements, the roles and responsibility of employee, contractor, and other stakeholder must be stated. Now, access control policies and procedure to manage user privilege and permission. So in the company or in the firm, everybody we don't have an equal right. Some as, they have more rights than the other because of roles. Now, so we have privileges or permissions, so that what you have access to is not what your boss or your HOD now may have access to. So, and for incident response and reporting guidelines to address security breaches. So these key elements of security policy, and I've explained the importance of security policy to us. So that is all about cryptography for tonight that I'm going to show. Now, what are the cryptographic key attack and what are the types? Now, we are talking about encryption, decryption, making sure our system, our information, or our message is secure over the communication. Now, what are the attacks that comes or that is associated with cryptography? Now, one of the attack is weak keys. Now, so keys are very essential and random number. Now, it can become more difficult to crack the longer the number is. So if the key strength or the length that is relative to the value of the data that is protected and the length of the time of the key or of the data rather that needs to be protected. So such key should be created with a high quality certified random number, so that information, the density of the file or the bit or the character cannot be, unauthorized access cannot gain access, to your information or to your messages. So the key must be strong. So if the key also that you use is not strong, hackers can try to, gain unauthorized access to your messages, because hacker, they use sophisticated tools, they're advancing, and that's also which we must advance in cyber security. You are not stereotyped, you learn every day, because new threats are actually evolving every day, and we have to be up to the task. Now also, so if I'm talking about what are the types of attacks that comes to, that face cryptography now. So if cryptography, the reason why we are actually, protecting our communication and data is that so that we can keep our keys also secure. So if one of the key, maybe from the sender or from the receiver or the recipient, anyone is compromised, now that kind of key can result in regulatory action, maybe fines or punishment, or reputational damage, and also loss of customer and investors. So it is very, very important that we don't use keys that are weak, and also incorrect use of keys. Now, so if keys that are used, or when keys that are used are not are improper, or they are encoded poorly, so it will become easy for hackers to crack. So when you are trying to use keys, so if that keys are not, used properly, and they are not encoded strongly or tightly, hackers can actually gain access to that kind of a key and crack it, so that what you think you are trying to protect is actually exposed. So another thing is that in encryption, don't try to reuse keys. So one of the reasons why hackers, or the challenges or the attacks that can face cryptography, is the reuse of keys. So every single key should be generated for a specific single use. So when you are trying to send a message to maybe A, don't try to use that same key. Do you get it? For B, for C, or for D, to encrypt and to decrypt. So because if you use it, if the hackers try the first one, when they want to gain access to your information, when they try it and they see that there's a loophole, okay, by then they can actually figure out the means at which you encrypt your data. So by that, they can actually gain access to your information. And also, is no rotation of key. So key should not be overused, so because it can become vulnerable to attacks. So don't use key. Key needs to be rotated. Now, when you try to, the way encryption, like maybe for example, I should come with a picture. Okay. Maybe for example, we have A, B, C, D. Now A to Z. Now, encryption, maybe your one, when A to Z, maybe A should be 1. Are you getting it? B should be 2, C should be 3. Now, that's the normal thing a normal person would think it should work. But your A can be 3. So they try to, the numbers are not arranged. It's not arranged in such a way that you can actually decode the message. Maybe your C now can be another word. Maybe your C can be 10, for example now. So you can't guess what the message is. So by that's what I'm saying, that don't reuse key. Maybe you now use a particular key to encrypt a message for A don't try to reuse that kind of keys for another person. So keys need to be renewed and updated as appropriate. So don't try to, reuse or overuse a particular key. Now, also we have an inappropriate storage of keys. Now, if you don't store your keys, so storing your keys alongside the information that have been created to protect the increase of the chances of being compromised. So that can be actually hackers or attackers or criminals can actually gain access to your information. So when you are trying to store your message or your keys alongside the information, make sure that you protect it in such a way that it cannot be compromised. Maybe, for example, you store a key on a database or in a server that gets breached. So that will actually lead to compromise and your data can be exfiltrated. Now, so that is the reason why those are the attacks that face cryptography and also inadequate protection of key. So stored keys, when your keys must be stored, your keys must be encrypted and only made available unencrypted and must be placed within a secured and untampered environment. So that's the challenges or the problems or the how will I put it, the attacks that is facing cryptography. So, and I think I'm going to stop there. Now, let me just say this lastly. So this encryption cryptography that I've been talking about now, one of the attack it faces most of the time also is that insider threats can actually pose a big problem. Maybe your another employee, your colleague, that you are working in the same environment. So if that person has access to the key that you use to encrypt your data, that also can actually, can use it for a malicious purpose and can give it that key even or sell it to hacker or third party that will have access to your message or to your information or to your sensitive information, your data you're trying to pass across. So those are the challenges that is facing cryptography. Now, how can we minimize the risk associated to cryptography? Now, the ways by which you can actually minimize the attacks that is associated to cryptography is that you must use a hardware security module to generate and protect keys and underpin the entire security system. So, and also another way through which you can minimize the risk or the attacks that are associated with cryptography is that we need to use a strong and a strict policy based on control, how we swift compromise detection and also key destruction. So when you finish using sending or encrypting a message and sending it over the network, over the internet, you must use key destruction. Also, use a strong user authentication also when you're trying to send message across or over the network, over the internet. So these are the ways by which you can actually minimize the risk that are associated with cryptography. And also, we should make sure that we protect our organization's keys. Because if we don't protect them, it can enhance efficiency. We should make sure we comply with the policy of the industry. It is very, very important that we comply with the regulations of the industry. So those are the ways by which you can actually, minimize the risk associated with cryptography. So these are the ways we can minimize the risk associated to cryptography. Now, the three types of cryptography that we have the secret key. I've explained that. Don't forget that is the secret key is symmetric and the public key is asymmetric, and we have the hash value. So that is the three types of cryptography: the secret key, the public key cryptography, and we have the hash function. So that's what I'm going to stop tonight. Now, and if you have any question, or excuse me, you can ask your question. Oh, sorry. Hope everybody was able. Hope you can all access what I sent to the group.
Yeah, we can access it.
We can all access it. And sorry, let me my water. Thank you. Thank you, Femi.
Kí làwọn eléyìí ṣe data? Wọ́n máa ti reduce data sí 9,000. Data that ẹ̀ ti sign that.
Who is that person that is talking? Please mute your mic like you want to speak. Mute your mic. Sorry, you have a question.
Yes,
Please,
I have
the
a
link.
question.
Okay. Go ahead, please.
All right. Today I was just reading about cybersecurity and stuff like that. So I came across something, and I just want to see like a clarification that when we talk about IT and cybersecurity, is it everything that is IT that has to do with cybersecurity, and is it everything that is cybersecurity that has to do with IT? So I just want to get is there any difference or similarities, or they are the same?
When you hear the word IT, right?
Yes.
Okay. The IT, when you hear the word IT, what is IT? IT means information technology. Do you remember? Do you get that? IT, when you just hear IT, because some people doesn't know the meaning of IT.
Yes, I know.
Okay. So information technology. Now, the difference between information technology and cybersecurity, I don't know if you remember our first class. I said information, when I was explaining cybersecurity, and I was explaining other types of sides of cybersecurity. I said cybersecurity has to do with you protecting your what? Can you remember? I talked about device. The difference there, I think I pinpointed that is that information security, it has to do with securing your sensitive data. Why cybersecurity? Your data, your device, your network. Do you get that? So information, the word information is there, has to do with information, your sensitive data, your sensitive information. So that is what IT. But when you hear IT, some people think it doesn't correlate with cybersecurity, or cybersecurity doesn't go. Everything is interwoven, because all what you are trying to do, both of you are trying to secure your information. Are you getting it? So for cybersecurity, you secure the device, you secure the system, the networks. Are you getting it? So that's the difference between the cybersecurity and information IT, information technology. So that's just the reason. That's just the difference. Rather, hope you are okay with the explanation.
Yes.
Okay. Sorry, please let me take water. Hello. Who asked that question, please?
It's me. Hello.
Hello. Okay. Let me just add this to it now. Now, so when you hear IT, now, IT, information technology, now, I said that one has to do with your information. Now, cybersecurity has to do also with information, but I actually explained the key. Now, IT also, they deal with the computer, the network, the software, and every infrastructure. But cybersecurity also is, the two words can be used, can be used exchangeably. Now, because cybersecurity also, it's focused on keeping your system safe from attack, and it's not only your system, your information too, your information, and your information is your data also. So your information secure from cyber attack. So IT and cybersecurity in some terms, or it can be used interchangeably. Shey you get? Hello, do you get it?
Yes, I got.
Yeah, so it can be used interchangeably, because sometimes when you see a job advert, they can say they are looking for an IT. And what does IT do? That has to do with computers and network, maybe software development or infrastructure sha. So when you see that, you can actually think, oh, I cannot apply for this role. But no, we have to understand that IT can be maybe the context at which they use it, but when you read the requirement, what they actually need, so you can actually fit in, or you have all this, then you can apply, because some people use the word interchangeably. So IT, computer networks and everything, but cybersecurity also, the major reason why we're actually, protecting our device, our networks, everything, from digital attack is because of our sensitive information. The reason why we are doing, trying to keep our network also, our devices, everything from digital attack is because of, what's it called? It's because of, from breach, from digital attack also, is because of our sensitive information. So the words can be used interchangeably. So IT can be broader sometimes, but cybersecurity is just an aspect also of IT. Let me say that also. So IT is broad. Do you get it? But cybersecurity is an aspect, of IT security, because IT is big. It has to do with computer software, different. Even in cyber security also, we have different domain or different aspects, and is broad. So by we are trying to, break it down, and everybody knows is our part, their part they need to play in order to secure the system. So I think you are okay with that, right?
Yeah. So it's okay to say that cybersecurity focuses on protecting electronic assets like internet, WAN, and LAN resources, right?
Yes, you can say
No.
that, because you can say that cybersecurity, has to do with, protecting your sensitive data.
Yeah.
Do you get it? It has
Yeah.
to do with just protecting people, especially the reason why you are protecting these devices and everything is because of people. People life depend on it, because since the world is now technical, technology, and the technology is advancing. So cybersecurity shared the common goal also with information technology. So it's just protecting people, device. It's just focus on just the different approach. Let me just say that different approach from which angle which you are coming from. So information technology, that one you see network, your hardware, your software, everything. So, but cybersecurity just have to do with your digital advice device and data from unauthorized access. That's what you must not forget about cybersecurity. Information technology, that one, everybody, we are protecting people also. It's just, we have the common goal. But for cyber security, that one just focus on systems, digital device just for data, so that your data will not be tampered with, so that unauthorized access user or people will not have access to your information, so that your data also can be available anytime you need it. So that is cyber security. I think that is okay with you and it's clear now.
Yes, and sorry, one last question about security, especially on a mobile device or emails, for instance. So, does that mean like any email that enters into spam, does that mean it's a threat to your security, or what? Or why do some emails enter spam in our
Okay.
yeah?
Okay. The root of email enter spam is, it can depend on your settings, and also it's designed in a way that when the email is coming, maybe you didn't apply for anything now, just send you a message. Do you get it? Maybe they can get your message, your mail from one of the websites you visit and things like that. There's a way they can actually gather mails and send you a mail. Now it enters spam because the source where the mail is coming from. Do you get it? The source from which the mail is coming from is not authorized. So
Yeah.
that is the reason why it enters spam. And sometimes, maybe you try to, maybe you apply for something also, but there's a way you're setting. Maybe you have actually blocked some things. Maybe when you check your phone or your system, maybe for, if it is, I'm just talking about phone now, system now, you can sometimes allow some kind of certain things to come, that not mail, not everything can just come on your system. There are some things, there are some mail and some source immediately is coming, your system, it will block it by the virtue of you setting it. So that's the reason why some mails enter spam. Is it okay with you? Are you okay?
Yeah, thank you.
Okay. So who else asked question? Okay, if there is no question, let's call it. And please, everyone that has not done his or assignment, at least have given grace to Sunday. That's yesterday. So everyone will be marked 0, which means you did not attempt it, you mark. And for those that attempt the the question and the rooms, I asked them to try it on Try Acme and did the assignment. You see your mark also. And also the assignment for week 2 is already in your Google Classroom. And week 3, please make sure you do it, because another one I'll be rolling out very soon, maybe by Friday, so that you not be overloaded. Make sure you do your assignment. Thank you, everybody. Thank you for coming to today's class. See you on Wednesday. Good night.